Hello everyone, and welcome to today's SANS DFIR webcast, When Macs Get Hacked. My name is Benjamin White with the SANS Institute, and I'll be moderating today's webcast. Today's featured speaker is Sarah Edwards, author of Forensics 518. If at any point you have a question for Sarah, please enter into the questions window located on the GoToWebinar interface. We'll be answering them throughout the webcast and at the end of the webcast. And with that, I'd like to hand the presentation over to Sarah Edwards.
Thanks, Ben. Well, we have a first slide up here. These are the current dates for the Forensics 518 class, the new Mac Forensic Analysis class that I put my life's work into, if you will. We just did the first beta in Vienna, Virginia. We had a great time with that. I had a great class. It was just good all around. So I highly recommend going to beta 2, half price. Let's see, Hal Pomerez is teaching that one. I will be attending the class. However, I will not be teaching per se. And Crystal City and Seattle, I will be co-teaching with Hal Pomerez. So come out and see me for those. Trying to get the slides to advance here. A little bit about me. Really quickly, I'm author of the Forensics 518 class. By day, I'm a Harris Corporation contractor working with federal law enforcement in the Northern Virginia area, mostly doing intrusion analysis, which is one of the reasons why I got interested in doing a Mac version of intrusion analysis, hence this webcast.
Muted.
And of course, I'm a Mac nerd at heart. I wait in all the lines, I get all the new phones and the gadgets and everything. I spend way too much money at the Apple Store. So why are we doing this? Why are we doing a Mac intrusion talk? Has a lot of the same current threats as Windows systems do. Insider threat, ad-click malware, backdoors. Even like one of the newest pieces of malware stole bitcoins from off of Mac systems. So it is coming into its own. One of the biggest ones, and this one's maybe a couple of years old by now, but one of the biggest well-known threats is flashback. This infected 600,000 systems, which compared to Windows malware is a drop in the bucket. It's nothing compared to the millions and millions of infected systems that Windows has, but it made national news. It was kind of a big deal. It was really a, oh my God, Macs really can get hacked now. Flashback came around due to drive-by downloads from compromised WordPress blogs. WordPress blogs we see all the time that get compromised. And this one shown in the screenshot, it will installs a fake Adobe Flash installer using a Java vulnerability. And Mueller. This one was interesting because it attacks normal OS X non-use of file extensions. So this one comes in usually via email, via zip archive. It installs a backdoor, does information stealing, but the big deal with this one is each one of those icons, one of them is highlighted, is actually a .app application. Each application on a Windows or on a Mac system has a .app extension to it. Now, normally OS X systems do not show users these file extensions, so you'll never see .app, you'll never see .jpeg. So it tempts the user into double-clicking one of these to see one of the lovely ladies shown here, and then it executes it as it would any other application. Once executed, it actually drops a normal JPEG into the directory that it was executed from. Crisis and or Morecut, depending on which AV company you look at. This one arrives, again, through Adobe Flash Player, very popular with malware. Never install anything with Adobe Flash in it, I guess, is the lesson taught here. This one comes in with WebEnhancer.class. The interesting thing about this is that it's cross-platform, meaning it will install, and we'll get into this a little bit later in the presentation, it has a executable for both Windows and Mac systems. Now, equal opportunity at this point. They're just missing a Linux executable now. And this one does normal backdoor access, screenshots, key logging, files and locational type data. Pint size, this one came out maybe a year or so ago. This one's kind of funny because if you looked at the infected users, we have major companies, Apple, Facebook, Twitter, Microsoft even. This is what's called a watering hole attack. The mobile developer forum iPhone Dev SDK was compromised through a JavaScript or a Java browser plugin 0-day, and the attacker in this situation knew that a lot of these companies went to this website with a vulnerable Java browser plugin. Another thing about Pint size that's interesting is that it bypasses Gatekeeper, which again we're going to be talking about a little bit later. Opens a reverse shell, has encrypted C2 communications, but then again it goes old school and hides itself as printer-related files, hiding itself kind of as a SVC host on Windows. It uses, hides in the obscurity of unknown system files, and it uses Perl scripts for communication. KITM, also known as Kumar in the Mac. This one was found last year at a Oslo Freedom Forum, and again it's a backdoor, a simple backdoor. It takes periodic screenshots. The kicker with this one is it was signed with a developer, Apple developer ID. So Gatekeeper, we talked about that a little bit before, but that either allows software to install or does not allow software to install depending on how the user has it set up. This was the first big one that came out that was signed by an Apple developer ID. So code signing is supposed to make software more legitimate. In this case, either it was stolen credentials or bad developer or what have you that made it malicious. So when we go up to a Mac, we'll need to do a little bit of incident response, live response, gather some of the volatile data, just so we can, once we do, shut down the system, do an image or do a live image, we have some files that we can go back to and look at for whatever was happening on the system when it was happening. Quick and easy little cheat sheet here of a few of the commands that you can use. You want simple information like date and host name. Those are two of the all these are native commands to OS X. They do exactly what they say. They give you the date, they give you the host name. uname-a will give you kernel and architecture info. And specific to Mac OS X is SW_vers, meaning software version. This will give you the OS X version. And that'll come into play maybe if you're doing memory analysis a little bit later to know which volatility profile you want to use for the system. Network information. We want to know where this, what kind of network activity the system has been having. Is it pinging out to certain places it shouldn't be? Is it does it have active connections to IPs it shouldn't have? What's going on here? So we IF config, different from Windows, IF versus IP config. This will give us the network configuration as it stands right now. netstat-am, we want to see active network connections. LSOF, list open files, and -I is specifically for network connections by process. So if you have a Dropbox, that's connecting to various IPs, and you'll see that in that listing. And routing table and ARP table. This will allow you to see current connections to various systems and systems that are located within your own network as well with the ARP table. Open files. We want to see what files have been opened. Often a simple keylogger will have a open file handle to its keylogged file. Maybe if we want to do a quick triage analysis, we can, review the processes, see what files are open, see if anything is just jumping out to us as malicious. Logged in users. Perhaps we have a case of bad admin, perhaps. Maybe we have multiple users on the system when only one is supposed to be a legitimate user. We want to take a look at who's been logging in and who's currently logged in. And again, you want to do a process list. PSAUX is the command to see what processes are currently running on the system itself. Systeminformation.app. This is an application that's built right into OS X. You can get to it either through the Apple menu or doing a spotlight search for systeminformation.app. Screenshot to you is shown here. Holds a ton of different information, hardware, network, software, various applications, log files, all sorts of great information. Now there is a command line interface to this program called system_profiler. Again, built into OS X. The command shown here gives you an XML output with detail level full. You can have, I believe it's like mini, medium, and full outputs. I go full because I want everything you can get. If you output this file into a .spx format, and it specifically has to have the extension SPX, you can again reopen it back on your analysis machine in the lab with the system information application and make it all nice and pretty for you. And again, it contains hardware, USB information, mounted volumes, kernel extensions we're going to be talking about a little later, as well as log data that we're also going to be talking about in a bit. Memory analysis. Volatile data is not complete without doing a memory capture. A couple of collection tools that I like, Mac Memorize, OSXPmem, and Mac Memory Reader. Seems to me like Mac Memory Reader is the de facto standard. Unfortunately, it broke a little bit. 10.9 introduced compressed memory, and it appears that only OSXPmem can handle that as of right now. So just an FYI, make sure you test your tools beforehand. 10.9 changed quite a bit as far as the memory realm is concerned. Now these memory dumps, different tools can be used to analyze these. Volatility is my favorite, of course. Again, it's the de facto standard in our industry. Ever since 2.3, they have full Mac support. You can also use Mac Memorize, which is Mandiant's tool, and Volafox. Gives you a few options there. Auto runs. We always hear about Windows auto runs. Mac has them too, go figure. The simplest auto runs that Mac OS X has, and these are ways of persisting on the box. Malware isn't usually that useful if it's not persistent through reboot, shutdowns, what have you. So login items are used per user. They're little applications that get launched when the user logs in via the GUI. I guess this would be similar to current version run on a Windows system. Locations here, you're going to find them in a plist. You know, everything in Mac is located in a plist, and anybody who's taken my class has already been sick and tired of plists by now, but hey, it's like the registry. So we have its own property list. Each user has one, com.apple.loginitems.plist. And if you're looking for the actual executable associated with said login item, you can go under the .app application, contents library, login items. Trying to read the questions. We got a volatility question here. Is there a volatility for profile for 10.9.2? I've had trouble finding one. There is one out there. I do not have the link for it in my mind right yet, but it is out there. Maybe ping Andrew Case. He'd probably hate me for doing this, but on Twitter, ATTRC, because I bet you he has access to one. Any tools available to do a remote memory dump? That's a good question. I want to say maybe F-Response does it, but don't take my word on that. As of right now, I do not know anything offhand that does that. Not saying that you couldn't run the same programs via terminal shell, via SSH, but have to get back to you on that one. Going back to auto runs, this is an example of login items here. This is the property list that I was showing you, telling you about before, and we have iTunes Helper. Hopefully you can see the little cursor thing I have on the screen. So that one points to iTunesHelper.app. We can also see the full path to where it's located in the path key here. And each user has their own login items. As we see here, we have iTunes Helper, Double Pane, VMware Fusion, all very legitimate applications. But you will, in some instances, see malicious login items here if they are here, in fact. No, I can't advance my slides. Oh, Ben, what did I do? Thank you. All right, launch agents and launch daemons. Now we're working up into complexity here with these. These are by far the most popular persistence location with current Mac malware that I've seen. Launch agents are user under the user context, while launch daemons are under the system context. Each one of these is, again, in a property list file. And if you would like to know a lot more about these, and I mean in granular detail, TechNote 2083 would be some very good nighttime reading for you. Again, launch agents, these are background user processes. They might have a limited GUI. It's very limited in this respect, and can have access to the home directory. A lot of the times a piece of malware, if it gets executed under the user process, it will create a launch agent. Well, if it gets created under system, meaning it had admin privileges granted to it, you know, it has a little pop-up window saying, hey, please log in with your admin credentials, it'll get created as a launch daemon. 3 locations primarily for these, each one in the system library, and the users library directory noted by the tilde. Each launch agents directory may contain a lot of launch agents. This one's an example of the system library launch agents. There can be upwards of, you know, a few hundred. And this is normal. You'll just have to do either timeline analysis, do hash comparison to know which ones are legit versus not legit. A couple of examples. The most important key you're going to want to look at here is the program or program arguments key. This is showing the user what is being launched and where it is being launched from. If we look at the middle screenshot here, we see item 0. This is user bin SSH agent, so this is the program that is needed to be launched, while item 1 is the argument to that program. So we have -I-L here, and then you can have multiple arguments, and you just add another item for it. Launch daemons, background system processes. These are located in very similar directories as the launch agents, except it's missing the user one because it's not allowed to be launched in the user context. So you only have 2 directories to look for here. But again, there'll be plenty to look at, that's for sure. Example of one here. We have one of the Unix periodic scripts. These are maintenance scripts, you know, do log rollover, clean out this, do that. This one is for the daily. So the program that it wants to launch is user sbin periodic with the daily argument. So there's daily, weekly, and monthly arguments that can be put with that script. The key start calendar interval. This basically tells the launch daemon when to run. We have hour, a minute here, 3:15. This means if the computer is up and running, I want you to run at 3:15 every morning. And this is going to be local system time. In the screenshot over here, I have one of the daily.out logs, example of it here. And we can see it actually running at 3:15 in the timestamp shown here. Again, moving up the complexity chain, we have XPC services. These are relatively new. I say relatively new, I think they came out about 10.7 or so. A lot of it is required for sandboxed applications. So each one of these services is a single application used for privilege separation as well as stability. So if the service crashes, it's not going to take down the whole system. It's only going to take down that specific application. And as far as locations, if you look in the application bundle, each application is actually a directory. It's not a file as you would see in on a Windows environment. It is the file, and you can find the actual service related to it in its own XPC services directory, as well as system library XPC services. Example of one you might see here. This one's Qt Kit Server, a QuickTime related XPC service. You see a bundle type code of XPC exclamation point as well as XPC service key here with a lot of the same variables and information that you can find in launch agents and daemons. A lot of these keys listed under XPC service. You'll find various, there's upwards of maybe 50 or 60 different keys associated with it that you can have. But look at the tech note for launch agents and daemons. For specific information about what does environmental variables mean, what does service type mean, it's shown here. I highly recommend that, especially if you want to go into a deep sleep. So examples, just to show you I'm not blowing smoke and making all this up. You can see here Flashback and Mueller both create a launch agents property list. Kumar in the Mac creates a login item. Crisis, with admin privileges, will create a launch or a XPC service. And Janicab, which is an older one, maybe a couple of years, maybe a year and a half, 2 years old by now, goes old school and creates a cron tab entry. Yes, you can still use cron tab for all you old school Unix nerds. Still available to you. So now we're getting into various vectors. Internet, a lot of them can be downloaded, can be executed by the user, drive-by downloads. These are some locations that you might want to check for to see if it came in via the Safari web browser. So the downloads list, maybe you want to just take a look to see what the user was downloading. Maybe they downloaded and clicked on something that they should not have. It's been known to happen in the past, that's for sure. So it's got the downloads.p list located in the Safari directory. Here we can see the URLs that it was downloaded from, the actual file that was downloaded and where it is currently located, as well as the file size. I've noticed in my analysis that the progress totals so far and the progress total to load can differ. In this instance here we have a difference of quite a bit, but I actually did download the entire file. Sometimes the plist does not get updated. I found it to be fairly buggy. Now the one downloaded here matches perfectly. So that's an Apple thing. We don't know why it does that. Maybe it has something to do with latency and read and writes. I don't know, but just be aware of that. And go to your downloads directory and see what is the actual file size and is it the whole file. Easy ways to check that. The history property list, and we want to look at Safari history, see where the user's been visiting. See maybe they got redirected, maybe they went to sites they shouldn't have been visiting. We can look in the history.p list for this. Now just showing you each item is a different visit to a certain website. We can see here the blank key, because Apple helps us out a lot, actually has the URL that was visited. The title has the page title, and the last visited date shown here is the WebKit, Cocoa, Mac Absolute Time, and there's about 4 different names for that timestamp, but it's not Unix Epoch, that's for sure. There's a great tool out there by Black Bag Technologies, Epoch Converter. If you are used to decode on the Windows side, this is the decode of the Mac world. Highly recommend you go to Black Bag and get a copy of it. Wonderful tool. Last session data. Last session property list is created and stored when Safari does not get quit gracefully. So if your system crashes, if you accidentally exit out of Safari without really meaning to, it actually still stores a lot of your session data. So this is what happens when you restart Safari. It says, would you like to restore your tabs? And you click yes please. This is where that data is coming from. So we see the key here, tab states. Each item underneath here holds a tab. So we see we have a tab open for apple.com, one for appleexaminer.com, and ICANN has cheeseburger because I want to look at cats. Now the big thing here is this session state data. This holds the history of that specific tab. So maybe apple.com was visited 10 tabs later after browsing websites that they shouldn't have been browsing. You can open and extract this binary blob data here, and it'll show it to you in another property list and other binary data. There was actually a bug a while ago, maybe about a month and a half ago, that got publicized because it stores user credentials in the clear. So if you're looking for people's passwords, it might be a good place to look as well. But that's a whole other presentation. Safari cache. We want to look at the cache because we want to see maybe the actual code of malicious code, different redirects, PHP, Java applets. This is what's going to be stored in your caches folder. Now, Apple has a couple of different places to store caches, and I'm going with the second one first. This is the standard caches, a standard way of storing cache data. It stores in a SQLite database, has the downloaded cache files as well as the metadata associated with them, where they came from and when they were downloaded. However, Apple also does, and I think this is fairly unique to Safari specifically, at least I haven't seen it in other browsers, is the web page previews. These are almost snapshots in time of what the user was browsing. We don't exactly know when they're created. However, we do know that they are created, and you can see here on the right an example of one. We can see a Google search, and we can see where the user clicked. So, I mean, not only just for intrusion investigations, but for any investigations, you absolutely want to take a look at these. You get some pretty golden nuggets of awesome forensic data because you're viewing exactly what the user saw and doing a looking at the MAC times associated with it. You can correlate that back to the Safari history data to know when exactly they were looking at it. So temporary and cache directories. If the user is browsing using Safari browser and maybe they get sucked into drive-by downloads or Java applets that want to run, a lot of that data will be stored in temporary directories, temp and /var/temp, as well as Java directories if it's Java specific. So under the user directory, there's a couple of locations where you can find this data: Java/temp and Java/cache. The cache is probably the most important because it's going to store the IDX and the jar files. And we can look at these files a little bit further. Each IDX file, and that was supposed to be in Courier. It's definitely supposed to look a lot prettier than this. Oh, PowerPoint. So we can see here that we see a few things. Where did it come from? This one's a version of the older SANS Webcast format that downloaded a .jar file. We can see an IP that it came from, as well as other information associated with it. However, this is not completely human readable, very human friendly. A friend of mine, Brian Baskin, created an IDX parser available on his GitHub page. And this can be either a Windows executable or a Python script. Hopefully everybody should be happy at this point. But screenshot shown here shows an example of one of those parsed IDX files. Well, we can see up here we have different HTML information, where it was downloaded from, what the jar was called, IP address, what is it the HTTP code was okay. Down here we see exactly what was downloaded with various checksums. So we see this WebEnhancer.class. We also see this Mac and this window, Win executables. This is that crisis Morecut example that I was talking about before, where it does the cross-compatibility. So it can either download on a Mac system and execute, or download a Win system and execute. Very cool stuff. Couple examples here. Flashback uses the /temp directory to store a lot of its files. For instance, it stores the Mako binary, which is the executable format for OS X, as .syscenter. Remember, for Unix systems, dot means hidden, so the normal user is not going to be able to see these files. Mueller stores a couple of its files, again, as hidden files in /temp. And Mac Control, which is a remote access Trojan, stores a lot of its files in here as well. We have bash script, malware, even a decoy Word document, because it does its infection via Microsoft Word doc. Another vector, email. We want to take a look at this. One of the threats I was showing you before is the one with the zip archive with the lady pictures in it. That social engineering will show you to double click on one of those. So we take a look at the Apple email. And just going over the Apple Mail application. If we look at accounts.plist, we can see which accounts were configured for each system. Each item under mail accounts is going to be a separate email account. Each directory, so each account has its own directory, and this is a mess. I'll be the first to admit that Apple Mail, and looking at it via just a terminal window or just in raw format without the help of various programs, it's ugly. You get nested message and attachment directories. You could have under various numbers and things like that. I mean, you can have just sizable nested directories here. A couple of different formats. We have Mbox format and Email X. For the most part, these are plain text email files. However, Apple Mail does add a little bit of XML data to it for a little bit of metadata. So things like maybe stuff with different attachments, whether it's flagged as a certain color, things like that. So you'll see this little bit of XML at the bottom of each message. So a lot of the things that we're looking at here are the various attachments directories. Shown in the screenshot over here, we can see, there's image.001.jpg. This could easily be, something .zip or something, just an executable format. Please install these critical updates, and somebody installs them. Apple attachments. A couple in the Apple Mail application itself. And this is an older version shown in the screenshot, but newer versions have the same functionality. It just looks different GUI areas. You can save Apple attachments in a couple different ways. You can save them, and saving them basically puts them into your default downloads directory, which in most cases is the user's downloads directory. Till the download shown here. Or the user can do a quick look. And quick look just brings up this little temporary window where you can quickly view the attachment and then exit out. So the user is not intentionally downloading anything, but it does get saved to the mail downloads directory in the user's library. Looking at each attachment, each time a user opens it, it saves metadata associated with it in the Open Attachments plist. Version of that is shown in the lower screenshot here. We can see when this attachment was last modified, when it was last opened, and where it was saved to. We can cross-correlate that back to, okay, this photo.jpg was saved to mail downloads. Okay, so we know that the user did a quick look on it versus a intentional saved. Some great information in there. Log analysis. Log analysis is really important. there are so many logs on Mac systems, going back to old Unix type logs. It's a great way to be able to tell the story of how the system was used or abused, as it were. So it's definitely worth taking a look at. Major log changes happened in 10.8. Before in 10.7 and previous, we had 3 main log files to look at. Secure had the security stuff, kernel.log, and system.log. All these are now rolled into just plain old system.log. There are, however, other logs that you should absolutely look at. And a lot of these are in binary format, so there is some process of extracting, compiling, and reviewing these logs as well. Apple system logs. For all you Unix guys out there, this is a syslog replacement. I'll use the air quotes for this one. Uses a lot of the same syslog formalities. In fact, you can actually review them using the syslog command. However, it's in a amplified binary format that other syslog commands can't interpret. You have to have a Mac system for this, unfortunately. So if we go into private var log ASL for Apple system log, we see a bunch of files in the format year, month, day, UID, and GUID. The UID is the user ID, while the GID is the group ID. So it is organized quite well. I mean, you could look at the screenshot here to say, okay, this one's for user ID 0, which means the root user, right? Or user 501, which is the first standard user. These can also be reviewed in the console.app. This is a built-in log analysis utility that we can use to review logs. And not just the current system logs on the system that you're looking at, you can import other logs into it if you want to use it for analysis. So a lot of the ASL logs are stored in system log queries, all messages here, as well as different diagnostic logs as well in the diagnostic section. In the console.app, if we do a search, and this one looks like it was a search for _process, we can see each log entry has a timestamp, a facility called login, and message and other information associated with it. This is not, however, all the information. If we go back one slide, we hit this blue inspector button here, we get this window pop up. Now this contains a lot more metadata associated with it. So if we just look up here, and user process is a user login process, we can't tell what user logged in. If we look at the additional metadata associated with it, we can see that the OOMPA user logged in and other information associated with it. So it's absolutely worth looking into if you're going to be looking at these logs. Make sure you're looking at everything. If we want to look and do a little bit more analysis, we can use the syslog command to parse a lot of these out if we want to do it in terminal. So syslog command shown here, -D is for directory. I'm pointing it right to the ASL directory. I'm like, just parse everything. Pipe it to more. We can see a lot of the same information is output to the screen as if we saw in the console.app. If we want more information, we can configure the syslog command to give us a little bit more info. -T, that allows us to view the timestamp in UTC. I like to do everything in UTC because time zones are hard. -F is for format. I like to use raw, and again, that's -D is for directory. The raw output is very similar to what you've seen in the screenshot here. It has square brackets around everything. It's easy to grep through. It's easy to import into Excel spreadsheet if you want to do it that way. And it has all the information. It's easiest for me, but it's really up to the user. They can play around with the syslog command. There's many other formats you can use. A different type of log, audit logs. These are not always looked at as well. Private var audit is their location. These are basic security module logs. These are, this came from Solaris of all places. And these are just security auditing logs. These are stored with a with another timestamp type output. So start time dot end time with year, month, day, hours, minutes, seconds. So we can see what the scope of each log is for. And again, these are binary, so we're going to have to use a utility to look into these further. We use the PR audit command with the -x and -n arguments to it. -x shows it to you in XML format, which I find is the easiest to read. And -n does a no resolve on the UIDs and GUIDs. It's kind of creepy to find that your user 501, which is usually yourself, show up in your evidentiary logs. So be aware of that. It will do a translation to the current user that you're doing the PR audit command. So we have an example here. Each one of these is a separate entry. So they do use multiple lines for one record entry. Be aware of that. This one is a SU, substitute user command. So user 501 was attempting to SU to root in this instance. The first one here we can see as a return is it was a successful. So we can see when the user performed the command, who were they at the time of the command execution, and where did they want to be if it was successful. The second one is a failure, and we see that failure unknown 255. We can see a lot of the same information: when it was performed, who was the relative user ID, and what were they trying to do. They were trying to SU to root. We also want to look for other sorts of privileged escalation type things with user logins and log outs. We want to see when each user was logging in, how long were they on for, what user were they on as, were they themselves maybe 501, 502, or were they a higher privileged user. So we could take a look at a couple of the ways that users are allowed to log in. The normal one, when you walk up to a system, you look at you sit down to the computer, you type your username and password. This is going to show up as your login window entries. Users, if they're computer savvy, can also open up via terminal and execute certain commands as that. Word of note here, each terminal session is a separate login process. So you might have one console process here when the user logged into the system, and 1, 2, 3, 4, however many terminal sessions open. So you might have multiple processes, login processes on at the same time. You can also remotely log in via SSH. This shows up here as SSH-D. And again, the last one of the four most common, that is screen sharing. Screen sharing is Apple's version of VNC. If you go to System Library Core Services, there is a system sharing.app application, and this is really just an amplified version of VNC protocol. We can see that it does very similar logging here, except it only has the username and the IP address that it came from. Now the first three use a very similar logging entry, user underscore process and dead underscore process. Each user underscore process is the login, while each dead underscore process is the log out. And we can correlate these back. If we look at this right here, this is the login process ID. We can correlate a full session by correlating these process IDs. So we can see that the user logged in at 15:07:29 and the user logged out of this particular session 15:07:51. So we can know exactly how long this user session was open for. Privilege escalation, again, we want to know if a user is escalating their privileges to either run a command or do other badness to the system. A couple commands that we do that with are SU and sudo. First example, SU, here we show an example of a failed SU. This will basically just show up as bad SU, the username to whatever user they want to substitute as. A successful one will show up as the username to root, depending on if they wanted to SU to root. You can also SU to any other user on the system if you have the permissions to do so. The sudo command, this is basically by by command itself. So it stores the information in a slightly different format. We see the user that it originated as, terminal window, the present working directory. We can see that they were in the documents directory when they executed this command. We can see whom they executed it as, and here it's root, as well as the actual command that was executed. In this case, it's iosnoop, which is a dtrace script. Nothing malicious in this case. Account creation. We want to see, if accounts were created when they were not supposed to. Maybe we have some insider threat. Maybe we have someone trying to persist, and their method of persistence is an additional account. So a couple of examples here. Word of note: this user was created at the exact same time, but I just wanted to show you the differences in log records to hopefully make you look at audit logs. I know they're a little bit more difficult to look at, but you get some really good data in there. So okay, this was the same event. The audit logs show you, a create user was performed, what user created it. We have user 501, when they created it, what the new user's name is called, and whether it was successful or not. This same command, when shown in the secure.log or the system.log on newer systems, we only see here that user ID 501 authenticated to the system preferences pane. It doesn't show us, what if a new account was created, what the name of the account was created, anything related to this new account. So just be aware of that. Different logs will show you more detailed information if you ask for it. And the install log. Naturally, you want to see stuff that was installed. For instance, the example shown in the screenshot is logkext. If anybody doesn't know what that is a open source OS 10 keylogger. Also makes for great presentation examples. Highly recommend it. In this install.log, we can see exactly what, where the executable was installed from. From here, we have the downloads directory. We can see if admin privileges are granted, administrator authorization granted. We can see it, admin credentials were provided. And then we can finally see, once it finally installed it, the end date timestamp for that. So we know exactly how long it took to install this particular keylogger. And this install log will also show you other things like, things installed from Mac App Store, anything that the user just about anything that the user double clicks. It won't install, or it won't show you other things that, like things installed via, like things like Mac ports or Fink or any of those package management tools. So be aware of what it does show you and what it does not show you. A volume analysis. Another vector we have here. We have a variety of different ways we can get malware onto the system. We also want to look at mounted volumes, maybe USB volumes or Thunderbolt volumes nowadays. If we look at the system log and the daily log, we can see that if we do a search for /volumes, we can see all the mounted volumes and when they were mounted. This can give us an idea of, the timeline and looking into it a little bit further. What was on this WD passport volume when it was mounted on the system. If we look on the kernel.log or system log in newer systems, if we do a search for USB MSC, we can get a quick look at what serial numbers are associated with the volumes that have been mounted. Apple does make a suggestion that these are in fact non-unique, and I have one highlighted here, which is definitely not unique. The example highlighted was from a conference USB drive that I got at some security conference somewhere. That was a cheap, crappy USB drive. It has the A through F, 0 through 9 serial number. So Apple reminds us that sometimes we can't in fact determine or correlate this back to a specific USB drive. But I'd say in 98% of all cases, these numbers are in fact going to be unique to some volume that's sitting by the keyboard or in the person's house that you can correlate back to. com.apple.finder. We can look at this property list here, and this shows us a lot of the recent folders or recently mounted volumes. If we want to look at mounted volumes, we can figure out it. Now, it doesn't have a correlated timestamp associated with it, but we can see where the mount point was, what it was called, and all the mounted volumes on that system, as well as recently accessed directories and folders. Antivirus. Mac does in fact have built-in antivirus capabilities. It's not great, but it is built in. File quarantine was introduced in 10.5. Uses extended attributes to tag certain files. A lot of the files that are downloaded through the big ones, the major browsers, the major email programs, will be tagged with this quarantine data. This, however, doesn't help us when we're doing intrusion analysis, because it doesn't tag files that are copied over from USB drives. It only does applications that specifically implement file quarantine. If we want to look at different applications to see if they do implement this file quarantine tagging ability, if we look at the ls file quarantine enabled key in the application's info plist, we can see if it is in fact enabled or not. In this case, we have an example of Google Chrome, which is one of the big web browsers. It is absolutely implemented there. A lot of this file quarantine data will also be stored in its own property list database file. Depending on the version that you're using, it's going to be called something a little bit different, but it's launch services quarantine events. Highly recommend looking into this, because it basically almost shows you everything that was downloaded on that system, whether it was through browser, whether it was through email or any other third-party application that implements that file quarantine data. If we take an example of one of the events from that database, we can see it has an event, unique event identifier, quarantine timestamp. We can see when this thing was downloaded, as well as what it was downloaded with. You'll see com.google Chrome, you'll see com.apple Safari, you'll see com.something.firefox. So you can know exactly which program downloaded that particular file. You see where it was downloaded from and the original URL string that it was pointed to. So if it redirects to download something, you'll see that original string, which would be very useful in some instances with malware if it does a lot of redirects to download various things. A lot of these nulls here, I just want to point this out, has sender name, sender address. These are used when quarantined from email programs. So you'll have the sender's name, their email address, and other email-related information as well. Like I said before, these are implemented as extended attributes. Extended attributes can basically hold any information that anybody wants, as long as they implement it. Shown here, we have a couple of different extended attributes examples. The ones that we're going to look at the most in this presentation is the quarantine and the KMD items where froms. And the MD items, the MD stands for metadata. A lot of this data will be indexed by Spotlight. So that's a whole other database we can take a look at later and review some of the metadata associated with it. So when you look at this in a terminal and you see this little weird @ sign at the end of the permission section, we know that this file has extended attributes associated with it. We can look and we can use the XATTR command, and I have the flags -x, -x, and -l. We can use this command to parse out those extended attributes. So we see a lot of the same information we saw before, where it came from, what was the URL that was associated with it, as well as timestamp information and whether it's associated with a browser or not. Some of this data parsed out. We see here we have quarantine timestamp, the agent name, in this case it's Google Chrome, a lot of the same information that we saw in that quarantine database. So we can cross-correlate this information. We have XProtect. XProtect is Apple's version of antivirus. It has 2 files associated with it. XProtect.meta.plist that has a lot of the metadata associated when it was last updated, blacklisted plugins, and XProtect.plist, which contains a lot of these signatures that it's looking for. Some of the weaknesses associated with XProtect. Apple updates it on Apple's terms. It does it when it wants to, how often it wants to. It's not up to the user to do that. It's Apple being helpful in doing it for you. There's very few signatures compared with other antivirus products. It's maybe, couple hundred, maybe not even that many. There's absolutely no heuristics associated with it, and it only checks quarantine files. So anything tagged with that quarantine data that we just talked about, it will check. But again, it won't check files dragged over by USB. It won't check files downloaded maybe with, through the terminal, maybe using wget, things like that. So be aware of its limitations. Example of one of the signatures here. This is the xprotect.plist. So each one has it stored in a pattern key here. If we extract that and view it in a hex editor, we can see exactly what the signature is looking for. It's looking for things in /temp. It's looking for, file.doc, things like that. A Gatekeeper, mentioned this right in the beginning of the presentation. Gatekeeper is a way to only run sandboxed applications. So the user has 3 different settings: Mac App Store only, Mac App Store and identified developers, and anywhere. Now that Kumar in the Mac, because the default setting is usually Mac App Store and identified developers, that Kumar in the Mac malware executed just fine if anybody had that setting. Just fine, because it was signed software. It was good to go. And just to end the presentation with a couple other files you may want to look at. Kernel extensions. These are very similar to loadable kernel modules if you're in the Linux world. They do things like device drivers, network filters, file system extensions, and also bad stuff. Keyloggers, example we have here is logkext. Again, this installs a kernel extension called com.fsb kext.logkext. So be aware, you might have malicious stuff hiding in your kernel extensions as well. And last but not least, we have the bash history. If somebody is on the box, either they did a su or they did a sudo to root or something like that, we can see their actions when commands are executed. By default, you'll have 500 entries in there. That is configurable. But pro tip here, run the history command as an incident response command if you have a logged in user at the time. The bash history does not get written until the user logs out. So if you do have another user, and we went over that with the who-a and the w commands very much earlier, we can see if any other users are logged in and run the command history for each user. Just to be sure, because we can see things like mounted volumes, network access, are they SSHing out to another system after this, different file and directory accesses, a lot of good information. And that just about ends my presentation here, and I'll get to some of the questions. I'm sorry I didn't get to them before. It's just a really hard window to be able to read. And I know Ben warned me of this, so I'll get to them now. Let me just make the window a little bit bigger. One question, using Activity Monitor, is there any value in running spin dumps or taking samples of a process? Sure. I mean, it's maybe if you already targeted a malicious process and you want to take a look at it further, I'd say go for it. Absolutely do it. Just be sure that you know the footprint that it's creating, because it will save it in a specific location, and it might, overwrite something. The same incident response issue that you get anywhere, really. But I wouldn't do that for every single process, because you might be there for a while. Next question. In my experience, do most companies try to integrate their Macs into their Windows AD environment?
Unmuted.
Do an open directory management structure? Do both open up similar risks? I have seen Macs being implemented with Active Directory. It doesn't work well. I work in a location where we try to do that, and it does get kind of flaky. As far as opening different risks, you know, as propagation goes, you're going to have access to it. I mean, if you have a domain controller, you're going to have their, you know, specific credentials that you're going to get anywhere. So yeah, there is the possibility that you could hop on the Mac side of the house and do whatever you need to do at that point. So yeah, I mean, the same risks apply. And for anybody who doesn't know, Open Directory is basically Apple's version of Active Directory. Next question, what tool and app are you using to view the plist files? A lot of the screenshots I have here is the default Xcode property list viewer. If you install Xcode, and anybody doing forensics should absolutely have that installed. It installs a lot of your developer utilities, property list viewing utilities, all sorts of good stuff. So yeah, I'm using Xcode. There is a couple other ones out there. There's trying to think, iBackupBot for Windows is about the best plist viewer I've seen on the Windows side. However, I wouldn't call it exactly the best I've seen, but your options get pretty limited when you're looking for, you know, free property list viewers on the Windows side. But Xcode all the way on the Mac side for sure. Do you know of a Python script or other tool that automatically scans the system and creates a list of autoruns on a Mac? There is a script out there. I think if you do a Google search for Mac autoruns, I'm trying to think of the website, but it's almost like evil something. Somebody has created a script for this. There is another tool out there as well. I'm trying to remember the name for it. Pack for Mac, something to that effect. That basically does a before and after of a system and determines if anything got messed with in between. So we're, you know, talking like evil maid attack. You know, you're in your hotel. You can set up this script. It does a pre-configured scan of your system. You come back to your hotel after, you know, a day at a conference. You can run it again and see if anything was fiddled with while you were away. But email me specifically, oompa@csh.rit.edu, and I'll get you the names of those scripts. I just don't remember them offhand. Does the history and download plist file get cleared if the user clears history within the application? Good question. I haven't tested that recently. I want to say yes, but don't take my word for it. Test it. That's the only way you're going to make sure you get the right answer. So if you know, whatever version of the browser you're running, it might depend on whether it's Chrome, Firefox, Safari. It might depend on the version. Each one is a little bit different. The best case scenario, test what you got and make sure you get your expected results. How well does log to timeline work on Mac OS X? Log to timeline worked great, but they're now doing Plazo. Plazo, I think, is getting into, they've been doing a ton of Mac development on there. Those guys are really hitting it hard on the Mac side. So if you've used log to timeline before, take a look at Plazo. It's basically the Python implementation of log to timeline by Christian Gudjonsson and his rockin' team of developers there. So take a look at that. Last I checked, it was still a little bit in beta as far as Plazo goes. Log to timeline was fairly solid, but Plazo is a little bit in beta. But I know they are working diligently and hard to make that the best log analysis tool that they can. All right, well, that looks like it's it for questions. Does anybody else have any questions? All right, well, if you want to get in contact with me, Email me at oompa@csh.rit.edu or catch me on Twitter at IamEVLTwin. Hope to hear from you soon.
Thank you very much, Sarah, for your great presentation. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.